Digital EBHS analysis. Abstract. The comfort of good NVH is one of the strongest brand differentiators. So good NVH performance is needed for luxury vehicles, while for others, any edges they can gain over competitors will pay back handsomely in brand equity and loyalty. EBHS stands for equivalent body hole size. It is one of the measure of vehicle NVH and climate control performance. The complete vehicle has to protect the occupants from external elements, water/air/noise/vibrations etc., and also should provide comforts with the help of HVAC, seats, trims and various sealing solutions. Keywords: EBHS, NVH, air, water, noise. Background. The tire/road interface causes airborne sound radiation from the contact zone as well as from the surfaces of the vibrating tire. It also causes structure-borne source transmitted as forces from the wheel into the suspension. The car engine also has both source components. Also body panels has holes, cutouts, said holes, air escape holes, mounting holes. If these holes are not plugged, these become source of poor EBHS. Due to the ever-increasing complexity of the body in white, BIW, it is a very challenging exercise to understand how noise propagates through the labyrinth of the vehicle's structure. Today, acoustic engineers perform ultrasound or smoke tests to identify these noise paths. However, this is only feasible late in the development process once prototypes are available, and moreover, the physical tests do not tell anything about the actual trajectory of these noise paths nor how to block them in the optimal way. Key points. 1. Need of digital analysis. Body shell baffle location digital analysis for sealing of airborne and acoustic leakage. 2. Preparation of single sealing surface CAD data with reference to latest release 60R CAD data. 3. Review the sealing surface by taking various sections and checking for continuity of panel section. 4. Wherever the continuity is disconnected, then check the same location in other sections for discontinuity. If yes, then it is identified as potential leakage. Overall noise level in dBA articulation index and thus sound quality of in-cab noise with the acoustic package including baffles in BIW should be in line with the vehicle level benchmark database. This target will be achieved by both the supplier and customer with care taken that body is well sealed. EBHS of the vehicle cab is 50 square centimeters and there is less structure-borne noise. Sound transmission is hence a very 2. Methodology details. Overall noise level in dBA articulation index and thus sound quality of in-cab noise with the acoustic package including baffles in BIW should be in line with the vehicle level benchmark database. This target will be achieved by both the supplier and customer with care taken that body is well sealed. EBHS of the vehicle cab is 50 square centimeters and there is less structure-borne noise. Sound transmission is hence a very complex problem with multiple aspects and of mixed air and structure-borne nature. It is hard to make a general split in frequency ranges between air and structure-borne transmission. It depends very much on the concrete application, but for car interior noise, the transmission path below 500 Hz is dominantly structure-borne and above 800 Hz. It is mainly airborne, but small components may vibrate and radiate at higher frequencies and large cavities may have important airborne components at lower frequencies. Identifying all potential airborne noise paths between the passenger compartment and the vehicle's exterior. Furthermore, it allows the engineer to improve the acoustic isolation by suppressing individual noise paths, using virtual plugs and sealants, using CAD data only. Traditionally, the first detection of environmental leakages into and from cabin have been dependent on physical prototypes. 2. Design for sealing and quality assurance process. A design process is developed to address cabin sealing and corrosion protection issues at design concept development stage. The process is based on a design approach of defining and continuously updating the collection of parts that form a strategic sealing barrier. Definition of a strategic sealing barrier enables virtual EBHS evaluation of nominal CAD assuming idealized sealants. Concept of body shell sealing surface. Detection, idealization of cabin sealing surface in CAD and checking of each and every opening for sealing design. Correction, physical verification of cabin sealing effectiveness by EBHS test. Troubleshooting for leak detection with reference to idealized cabin sealing surface. The EBHS performance is improved drastically post-digital EBHS analysis. The EBHS value before digital EBHS analysis process. EBHS values post-digital EBHS analysis process, hatchback, sub 4 meter, CUV. V improvements of methodology. 1. Identification of air leakage paths in early stage of project is possible and can relate physical test. 2. We can analyze the leakages in CAD stage only, which can be iterated many times. 3. Potential leakage path analyses is done in CAD review and solution can identify such as plug, expandable tape, or baffle in CAD data phase itself. 4. The time required to meet PAT target for EBHS is lesser in time if compared with physical test. 5. Quick response for solution can be generated and physical test can be done for confirmation. 6. Identifying all potential airborne noise paths between the passenger compartment and the vehicle's exterior. 7. Can avoid the uses of costly solutions during vehicle launch to tackle issues related to sealing requirement. 8. Digital audits for sign-off and quality assurance by check sheets. 9. Increased customer comfort and quality perception during vehicle usage. Car cabin sealing POC 1.